Question 11. This question is about time of flight mass spectrometry. So what time of flight mass spectrometry does, using a time of flight mass spectrometer, which is the instrument used to measure it, it measures mz values. M is the mass of a particle divided by its charge. Well, we'll make sure its charge is +1, and we'll talk about that in a little while. And so mass divided by 1 is just its mass. I've got an element Q, and I've got different masses for element Q, 82, 83, 84, and 86. That's because element Q has different isotopes. They're atoms with the same number of electrons and protons and the same atomic number, but different numbers of neutrons, and that's why they've got different masses. They've got different abundances, so different amounts. So I've got 5 particles mass 82, 3 particles mass 83, 26 particles mass 84, and 7 particles of mass 86. I'm going to work out the masses all together. So I've got 5 particles mass 82, so their mass is 410 altogether. 3 particles mass 83, 3 times 83 is 249, so that's the mass of those particles. 26 particles mass 84, 26 times 84 is 2184, that's the mass of those particles. And 7 particles mass 86, 7 times 86 is 602, that's the mass of those particles. Added all together, the total mass of all of these particles altogether is 3445. Now the total number of particles is 5, add 3, add 26, add 7. Total number of particles is 41. So if I was going to work out the average mass of a particle, I take the mass of all the particles, 3445, divided by the number of particles, 41, it comes out as 84.0. I can look that up on a periodic table, and the element with a mass of 84.0 is krypton. A sample of element Q consists of several isotopes, we've determined that already, and it's ionized in a time of flight mass spectrometer. So what actually happens in a time of flight mass spectrometer is you take the element Q, you ionize, in other words turn them all into plus charge ions. You can do that with something called an electron gun, which is you fire electrons across the tube, and as an electron hits an atom, it knocks another electron off to make sure the atom then is plus charged. It's accelerated along the tube towards some negatively charged plates. It hits a detector at the far end, which detects how quickly it's gone along the tube. The faster it's gone along the tube, the lighter the particle, the lower the mass, and the slower, the longer it's taken to go along the tube, the heavier the particle, the larger the atomic mass. Therefore, the kinetic energy of each particle is always the same. So it doesn't matter on the mass, the particle has the same kinetic energy. And we've been given the equation for kinetic energy as half mv squared. M is the mass of a particle, v is its velocity squared, so it's speed squared. And the mass is in kilograms of one of the particles, one of the ionized particles. So let's have a look. We've got 82Q. And we've got 86Q. They're both charged plus because they've both been ionized, turned into ions by removing an electron using something called an electron gun. So the mass of 1 mole of 82Q is 82 grams, that is. Divide by 1,000 to turn grams into kilograms. So we're going from a small unit up to a larger unit, divide by 1,000. The mass of a mole of 82Q is 0.82 kilograms. The mass of one single particle, we've got to divide by the number of particles in there. Avogadro's number is 0.082. Divided by Avogadro's number gives me the mass of one of these particles. The kinetic energy is half mv squared, so the kinetic energy is half multiplied by the mass of one of the particles, 0.082, divided by Avogadro's number to get the mass of one of the particles rather than a mole of the particles, multiplied by velocity squared. So I'm just going to multiply these two out. Half times 0.082 is 0.041, divided by Avogadro's number, multiplied by v squared. I do the same for 86Q, 86 grams, 0.086 kilograms. The mass of one particle is therefore the mass of a mole of particles, 0.086 kilograms, divided by the number of particles in a mole, Avogadro's number. That gives me the mass of one particle now. So the kinetic energy is half multiplied by the mass m of one particle multiplied by v squared. Half times 0.086 is 0.043 divided by Avogadro's number to get the mass of one particle and multiplied by v squared. V squared is not the same in each of these because the velocity of this lighter particle 82q will be going faster than the heavier particle 86q. But one thing I do know is that the kinetic energy of each of these is the same. So this value, 0.041 divided by Avogadro's number times v squared, is the same as 0.043 divided by Avogadro's number times v squared for this particle, because the kinetic energy of each particle, every particle that goes into the tube, is the same. So now I can say 0.041 divided by Avogadro's number times v squared for 82q equals 0.043 divided by Avogadro's number times v squared for 86q. I haven't got Avogadro's number, but it doesn't really matter because I can cancel it on both sides. So 0.041 times v squared for 82 equals 0.043 times v squared for 86. Now, I've been given something else. V is distance divided by time. So if I substitute v for d divided by t, then v squared is v times v, or d divided by t times d divided by t. So I've substituted v for d divided by t, so 0.41 times d divided by t times d divided by t is the same as equals 0.43 multiplied by d divided by t divided by d divided by t. The distance of the tube isn't changing, it's the same instrument. So now I can cancel the d's on each side. So now 0.41 divided by t squared is 0.43 divided by t squared for 82 and 86q respectively. The time isn't the same. 82 is lighter, so it's going to go faster, so it's going to have a lower time to go down the tube than 86, which is heavier and slower. I'm going to have a higher time, a higher t. But I have been given the time of flight, 1.243 times 10 to the minus 5 seconds for 82. So I've substituted that in now, and I've calculated this. 2.65 times 10 to the power 8 equals 0.83 times t squared. That should be 0.43, not 0.83, sorry, 0.43 divided by t squared. That's an error there, 0.43 divided by t squared. And so t squared is 0.43 divided by 2.65 times 10 to the power of 8, 1.623 times 10 to the minus 10. That's t squared. Square root it. T is 1.273 times 10 to the minus 5 seconds.